We're about to start our plenary session, and I would like to briefly introduce our speaker, my colleague, Professor Daniel Sgroi. Daniel is Professor of Economics, specializing in applications of psychology, cognitive behavior, language, and beliefs to understand economic decisions. At Warwick, Daniel is coordinator of the Experimental and Behavioral Research Group in the Economics Department, and also lead of Behavior, Brain and Society, one of the global research priorities at the university. Outside Warwick, Daniel is a member of the World Wellbeing Panel and an affiliate of the Behavioral Data Science Research Program at the Alan Turing Institute. We have invited Daniel to speak here to economic historians. You wonder why. The reason is that Daniel's interests in individual behavior and well-being are closely tied to the economics of happiness, which led him in an ambitious project to measure people's happiness over the past 200 years. On this subject, Daniel has written papers such as historical analysis of national subjective well-being using millions of digitized books, or measuring national mood with music using machine learning to construct a measure of balance from audio data. As you can imagine, Daniel's work has received extensive media coverage, and I hope that by the end of this talk we are able to answer the question, are we happier today than people ever were? Or were our ancestors happier than we currently are? So we are delighted to have Daniel Sgroi here to talk about measuring national well-being in the past, and you have until 45 minutes.
Thank you very much. Thank you, Claudia. Thank you. So I want to thank everybody involved in bringing me here, Vishnu, Claudia, so many other people, and also Maureen, Alice, so many people who've been organising today's and the whole conference. I have to come clean, as you heard, I'm not an economic historian. That means I'm a bit of a fake in front of this audience, but I'm going to do my best. I am an economist, but in terms of what I'm going to talk about today, you might be better off thinking of me as a behavioural scientist, or perhaps even better than that, a behavioural data scientist. Unfortunately, Claudia revealed a few things that I was going to reveal slowly during the talk, but that doesn't matter. That doesn't matter. Okay, so I'm going to cover a lot of work. I'm going to cover the two papers that Claudia mentioned, and when I get to the end, I'm hopefully going to cover what I'm working on now and ideas for the future. But how much I cover depends on how much time I've got. The main thing I want to do in today's talk is not just talk about national well-being in the past. I want to convince you that some of the techniques that I'm going to discuss, some of the data science techniques, can be used to perhaps answer the sort of problems that you might be interested in. So it's not just about national well-being. You might not be interested in national well-being, but you might still be interested in the sort of techniques that I'm going to discuss. I am nevertheless going to spend 2 whole slides to try and convince you that national well-being is interesting and important, right? But if I fail, it's not all over. Okay, so here we go. Why do we need a measure of national happiness, and particularly a measure that extends into the past? So let me start off by making an obvious point that everyone in the room will know. We have fantastic national income data, absolutely fantastic national income data, which of course was collected and has been collected consistently since the 1930s, but much, much more than that. Many fantastic economic historians, and I can see some of them in the room, have been involved in rolling back the data we have to the distant past. Stephen Broadberry's just there. I was lucky enough to coincide with him for a number of years at Warwick, and I know that he and so many others have done some incredible work rolling the data that we've got back centuries. Compare that with happiness data. So we have survey data going back to the 1970s for some countries, particularly for some European countries. We have the Eurobarometer, which is a well-known survey from about 1972 onwards. The Eurobarometer included a question about national well-being. But for much of the world, we only really started collecting consistent data when the World Happiness Report kicked off about 10 years ago. So the comparison is dramatic. 10 to perhaps 50 years worth of data versus centuries worth of data. So it's no surprise then that national income has been an important measure of human development and has been talked about by economists and historians for so long, whereas national happiness seems to have taken a back seat. However, even though we have so much more and so much better national income data, I still think it would be wrong to think about national income as a good proxy of national well-being. There are many obvious reasons why it's not a good proxy. So Simon Kuznets pointed out, again, this may seem obvious to you, but for many people it's a surprise. Simon Kuznets pointed out that when we measure GDP, as we're arming in preparation for a war, GDP goes up. But a war is hardly a great indicator of human well-being. Right? So it seems strange that our proxy for human well-being, national income, is going up just as we're preparing for war. Similarly, think about the environment. The BP Deep Horizons oil spill, one of the worst individual environmental disasters in recent history, actually increased US GDP. The cleanup operation was so large, you can see a little upward tick. Again, if these two statements are read properly, that means if we want to improve human well-being and we're using national income, we should be in the middle of wars and we should be spilling oil all over the place. Clearly, that's not sensible. And there are so many other things I can draw from microeconomics, various measures of health, etc. The most obvious being, if I decide to retire early, that's a choice, suggests that my well-being is going to go up, otherwise I wouldn't do it. But my income goes down, so clearly a measure of income and a measure of well-being don't seem to be in perfect alignment. And then we have the Easterlin paradox. Many of you will have heard of this, but Richard Easterlin pointed out a number of years ago in his seminal study that there are countries out there that have relatively low levels of GDP, but their happiness level doesn't seem to be commensurately low. That is a highly controversial statement. Many people would disagree almost violently with that statement. I'm going to make one point here, and I'm going to return to that later, which is it's actually very difficult to know for sure whether the Easterlin paradox is true or not, because so far we've been assessing it using cross-country data. We've been comparing a rich country with a poor country and comparing the relative happiness of those two nations. That's not exactly a great comparison, and we'll see later when we actually have access to a long-run set of happiness data that we can finally assess, maybe properly, whether the Easterlin paradox is correct or not. Final thing I'll say, even if you absolutely despise national happiness, you're not interested in well-being, all of these things are irritating to you, you still have to accept that as a policy-making device, we need to understand national happiness now. It's used consistently by many governments, including our own, to determine whether policy should go ahead or not. And if we don't have the sort of quality of data that we have, say, with national income, we're always going to be giving bad advice, and we're always going to be making mistakes if we try and use national well-being as an indicator for sensible policy. But that begs the question, how do we address the fact that we have such a terrible amount of data for national happiness? How are we going to deal with this? Since we collect happiness data by asking people questions in surveys, we can't easily rectify this. We can't invent a time machine, go back in time and ask people 100 years ago. It's not going to be possible. We're going to have to think outside the box. And this is where behavioral data science kicks in. So first of all, I'm going to discuss language. So psychologists have shown us, and have told us repeatedly, that you can extract from language an idea of mood. Not just happiness, you can determine from the mood, from the language that people use, whether they're afraid, aroused, excited, angry, and whether they're happy or not. And this is not a new or astonishing revelation. This has been used for many years in many different industries, many different disciplines, many different professions. Psychiatrists might get you to keep a diary if they're worried that you might be dipping into depression, and they can use the words in that diary to try and ascertain maybe what's triggering your depression. A criminologist or perhaps the security services could look at your blog posts to see if you're imminently going to commit a crime. Marketing teams might look at your social media posts to see if you're receptive to a new product, etc. So text has been used for many years in many industries to try and extract information about preferences and about mood. What we're going to be doing is we're going to be taking that up to the sort of macroeconomic level by, instead of looking at individuals, we're going to try and ascertain the well-being of the entire nation, not by looking at an individual's blog post, but by looking at all the literature that's been published by a particular nation or in a particular nation in a given year. So that's essentially what we're going to be doing. And working with some psychology colleagues, we essentially took a load of words extracted from millions of books and newspapers. We extracted the mood from those, and we constructed effectively a weighted index of implied happiness going back a few centuries. So let me move on to show you exactly how we did that. So if you're going to try and work out a measure of mood for an entire nation, you're going to need two things. The first thing you're going to need is data, of course, and the data that we use, language data, tends to be generated by, say, digitizing books, digitizing newspapers. There are many such data sources, and we use many in our work. Probably the most famous is the Google digitization project. They've digitized millions of books and made this freely available for academics, for anybody to look at. After this talk, not during, or you won't listen to a word that I've got to say for the rest of the talk, but after, just go into your browser and type in Google Ngram, literally as it said there, N-G-R-A-M, press return. You'll get the front end of the Google Ngram or digitization project. You can type in any words you like, choose any corpus that they've digitized, and look at how often those words have appeared in the English language or in the German language or in the French language for the past 500 years. You can go right back to 1500 and see how many times the word Oxford or the word Cambridge has appeared, and you can compare the two and see which university was more or less important across the last 500 years, to your heart's content, and spend the rest of your life doing that. Or you can do much more productive things, which is what I hope we did. The second thing you need, having a data set is not going to be quite enough. You need to convert those words, the quantity of words, into numbers. So if we're going to create a weighted average, we need to be able to convert words like happiness, vacation, murder, death. We need to convert them into numbers that we can use to tell us how happy or sad the nation was at any given time. To do that, we use what are called word norms from psychology. In psychology, these sorts of word norms are often described as valence norms. Valence is virtually the same as well-being in psychology, but in particular for text, you'll often see psychologists talking about text valence. That means the mood that you can extract from individual words. These are some examples from one particular psychological norm, and this was generated by asking a bunch of people how these words made them feel. There are many such norms, and we used a variety in our work. We have used and continue to use a variety in our work. But this one is called ANU, Effective Norms for English Words. It rates words between 1 and 9, and some examples are here. Happiness, 8.53 out of 9. Enjoyment, 8.37. Relaxing, 8.19. You go down to the low end, murder, abuse, die. These are getting much lower scores, as you would expect. Okay, so these two things together give you pretty much all you need to know. We're going to need to do an awful lot of work to validate and to check for robustness what we're going to do. But essentially what we're going to do is take all these words, convert them to numbers, and construct a weighted average. So think of it like this. If there are only two words in the English language, and they were happiness and murder, and people used happiness really a lot, but only used murder a few times, and then suddenly they were using the word murder a lot more often, clearly the valence index is going to go down. So that's essentially all we're going to do, is we're going to construct weighted averages using these sorts of numbers and looking at the words that people have used for the past few centuries. I'm going to give you a little more detail. So first of all, we selected a core of 1,000 words. We wanted to do this because we wanted to use the same words again and again and again every time we used a different country. So we wanted to make sure that a word we were using in English was also there in German, French, Italian, etc. So this core of words, norms exist across many different languages. Next, as I said, we calculated a weighted average, and we rolled it back as far as we thought was reasonable. Now, that's a big statement, as far as we thought was reasonable. We didn't just make that judgment. We did the right thing, I think. We went and talked to people in English literature departments, history departments, modern languages departments, and we asked them, at what point do you think words in a language reflect the people in that, the population, the average person? That's an important question. In 1500, that would not be true. It reflects a small elite that can read, a small elite that can write, and most of the books around in those sorts of periods of time are going to be about religion, about law, about philosophy, etc. The answer we got was not always the same answer, but typically it ranged between around 1800 and 1820. And the idea was that around about then, a load of things happened. Literacy rates are pretty good. We've got the novel becoming a very important form of book. We have the publishing industry becoming prominent, a variety of things happening. The birth, from English literature, of course, the thing we were told, the birth of things like critical realism, a whole bunch of famous authors, many of whom you've heard of, Dickens, George Eliot, and the equivalent across the whole of Europe appeared. So around about 1820 onwards, we think it's fair to think of the words that appear in things like books and newspapers to reflect, in some sense, the mood of the nation, in the same way that a current blog post might reflect the mood of an individual writing that blog post. We also use the idea of an efficient, competitive publishing industry a great deal. This is important. The idea of a publishing industry for us is that it acts as an intermediary. We get a whole bunch of people submitting possible books, authors. The publishing industry looks at that set of books, decides which book is right for the audience, for the readers, and then that book gets published. And that, for us, is a sign that somebody somewhere has selected a bunch of words, in other words, a mood that they believe is in alignment with the mood of the nation. So that's the sort of model behind all of this. But of course, these are all assumptions, and we need to test all of these things. A lot of what we're going to do, and what I'm going to take you through for the rest of the talk, is going to be about validation and robustness. Are these reasonable things to do? And if so, what do they tell us about happiness? So the first thing we did, which is, of course, the first child's play, is just to form a correlation. So what we have here is what I'm calling the National Valence Index, which is remember, the weighted average that we develop based on words. So a lot of happy words means it's high, a lot of sad words means it's low. And we correlate that against survey-based life satisfaction taken from the Eurobarometer. Those two measures, our measure, the NVI, the National Valence Index, and survey-based life satisfaction data coincide between 1972 and 2009. And that's because we stopped measuring this at 2009. I'll explain that later if I have time. But essentially, we have a bunch of data where we have survey data and we have our measure of well-being based on books and newspapers, etc. What we see is it's a reasonable correlation. We also see that it's positive. This is important, and I'll come back to this. It might not have been positive, but it was. Again, this is a result, not an assumption, and I'll come back to that. More formally, we need to do a lot more than look at correlations. Don't worry, that was step one in a 10-step process. But the next thing we wanted to do was think about putting in controls and thinking about how robust this relationship is when we start adding things. So we slowly put a bunch of things into our model. These are two very simple ones that just indicate that our index does predict life satisfaction pretty well. But we added a whole bunch of things that you would expect to see, including things like literacy rates and measures of freedom, etc. We want to know that books and newspapers aren't being controlled, they are really reflective of what people want to read, etc. We threw all these things in, measures of democracy, all that sort of stuff, and it was always absolutely fine. We also checked that words with high valence, words like happiness and vacation, for example, occur significantly more often at times of higher life satisfaction, whereas words like murder and death occur when you'd expect at moments of low life satisfaction, when the two coincide, between 1972 and 2009, where we have both sets of data. I mentioned that positive relationship. That's important. That tells us that as a nation, on average, the average person in, say, the UK, during a moment of extreme happiness, is reading a happy bunch of words. That's not trivial. At the individual level, we might worry about that. If you're feeling miserable, you might not necessarily think to go and pull out an extremely miserable book to read. But what we see is that as a nation, that is indeed what we do. We wallow in it when we're sad, right? Which I think perhaps makes sense, but it's a result, so I can't say any more about it. The next, and probably most computationally onerous thing we had to do, which I think took about as long as the whole rest of the project combined, was to solve for an incredibly difficult problem. I can describe that problem very easily with reference to the word dig. So in the 1930s, take the word dig, and it means to use a spade, and you move dirt around. So, and this is important, the word dig is surrounded by words like dirt and shovel. Fast forward to the 1970s, and the word dig is not so much, well, it still is, but it's not always surrounded by words like dirt and shovel. Now it's surrounded by other words. Clearly, I dig you, man, doesn't mean I'm attacking you with a shovel. It means something else. And that tells us that the word dig is not a stable word. It's a word where the meaning is fluctuating over time. And we need to control for this. Or at least, we need to control for this in order to satisfy referees. Slightly different statement, right? And we did that by doing something computationally nightmarish. And this is where the affiliation with the Alan Turing Institute is very important. So our previous index was relatively straightforward. It's a weighted average. We can now construct a stable version of that by looking at hundreds of billions of words, going back through time, and looking at the words in the neighborhood around those words, and making sure that those words that are in that neighborhood remain more or less the same. And then we order every one of our 1,000 words based on how stable the neighboring set is going back through time. That took about a week in the cluster of computers at the Alan Turing Institute to run. And that is impressive when you think it takes about 10 seconds to run a regression in Stata or in R. So it gives you some idea of the scale of this. And I think that maybe in 5-10 years' time, it'll take 5 minutes. 50 years ago, 10 years ago, it would have taken forever. So we did this just about when we could do it, I think. What we found when we constructed this stable version was absolutely no change in our index. So we satisfied the referees, they were very happy, but it didn't actually make any difference. And the reason why it doesn't make any difference is obvious if you think about this for 5 seconds. We're dealing with big data. I mentioned the word hundreds of billions of words. I wasn't exaggerating. So if you take hundreds of billions of words and you just remove all the unstable ones, so you're left with, say, tens of billions of words, you've still got an awful lot of data. It's not really going to change anything. The law of large numbers is somewhat satisfied at that level. Right. Obviously, the other thing we need to do, which we did, and which I would encourage you to do if you ever do this sort of thing, is to use many different corpora, many different sources of language, many different norms, and you'll find, of course, that nothing changes, but again, you'll make referees happy. Right, now let's look at what we actually discovered. So there's a lot of things to say about this. This is one index. This is the index for the UK, using Google Books, using ANU, effective norms for English words. There are clearly many that we can reproduce using this methodology. Some things to point out. Firstly, I've highlighted a couple of important periods of time, 2 world wars, and I've highlighted them because of the slopes, the gradients, not necessarily the levels. This is important. What we know through studying happiness and understanding happiness a bit better now than maybe we did 50 years ago is that happiness is an entirely relative concept. So I might not be happy right now if I don't think my phone is up to scratch. 10 years ago, I might have been happy if I had a smartphone. 20 years before that, a phone. 40, 50 years before that, a carrier pigeon, right? So things change. So we can't reasonably compare happiness levels in 1975 with happiness levels in 1875, because when I ask how happy you are, which is what we're doing with the text, we're effectively emulating the survey, these things are not really comparable. However, we can look at levels, we can look at gradients. So if we think we have an accurate measure of well-being in 1975, it's probably similar to the measure in 1974 and 1976. So if we see any swift movement up and down, we can be reasonably happy that that's a valid comparison. That's why these extreme slopes are particularly interesting. And we can see collapses in World War I, World War II. We can see an upward bounce, and we can see another downward bounce. And these correspond, obviously, to important things. So we're out of World War I, but then we've got the Great Depression, or there's that period when everyone thought World War I, World War II was going really well, then it wasn't, then it was again. I mean, you can pick up a lot of the things that are actually going on. But let me move to a period where I'm starting to know a little bit more about what I'm talking about, which is moving towards the 1970s, where I appeared, I guess you could say. So in particular, though, if you take the post-World War II era, there's a nice thing about our index. I really love this. This is my favourite bit of the entire talk. 1957 was the peak of the post-World War II era in our index. It was also the moment when Harold Macmillan said we never had it so good. And he was right. But he should have said, and we won't have it so good ever again. So according to our index, that's what he should have said. What's even more interesting is we get a slow decline. That's probably, again, I'm pulling in some happiness economics. That's probably because aspirations were crazily high in 1957, too high, unfortunately. So happiness levels drift downwards. And what we see is it going right the way down to this other period of time, 1978 to 79, which has this wonderful name for us, the winter of discontent. So literally our national valence index is bottoming out at the point when people talk about there being a winter of basically unhappiness. They could have called it the winter of low values for the NVI. That would have been just as good as far as I'm concerned. So our index is picking this up absolutely brilliantly. Of course it drifts upwards after that. The very observant of you can see it flattening out at around about 2008. Unfortunately, we didn't collect any data after that, but I think we could probably go back and have a bit of fun looking at the last 15 years or so and observing what the index does. But I suspect we all know what happens to the index after that. So let me summarize a few things before talking about music. Could someone remind me when this stops, by the way? 45, okay. I don't want to just keep going forever. But okay, so just to summarize the key results from our index, what can we do with it, having painstakingly constructed this index? So we can say a few things about happiness in past. Firstly, we can finally address the Easterlin paradox using longitudinal data. So we don't have to use cross-country data, which is subject to all manner of cultural differences, all manner of difficulties. We can finally look at longitudinal data, and we can say, at the end of all of this, that the Easterlin paradox is sort of maybe okay, but maybe not. So in the end, I'm not going to say anything particularly definitive. So GDP does correlate with national happiness, but not very much. So there you go. Hopefully I've managed to alienate both sides of the argument at the same time. But I'm not even going to reveal what that number is. We did in an early working paper, then we removed it, partly because it's a slightly non-linear result. Exactly as you'd expect, GDP correlates, or at least the effect sizes are bigger early on in the history of the UK, and they shrink over time. This makes perfect sense. You'd expect to see bigger effect sizes when a country's average person is closer to subsistence, because as income rises, it's pulling you away from subsistence. When you get sufficiently rich, it starts to become less important. So essentially, everything you would think about logically shows up in our index. But what that means is for the past 200 years on average, there is a correlation, but the effect sizes are relatively small. A more linear and perhaps maybe stronger effect comes through health. Now, we don't have a measure of national health to look to compare with our NVI, but we do have two reasonable proxies. We have life expectancy and child mortality, and they both correlate very well with the NVI over time. So that's nice to know. The other point, which I've sort of already made, is that conflict is really bad news for a national well-being, exactly as you'd expect. Good news for GDP, but not such good news for well-being. So I can go back to my early slide and say I think probably Kuznets was right on that one. Okay, so now I'm going to move on and talk about music. Why do I need to talk about music? Language seems to be doing pretty well. Not as well as you might think, not because it doesn't do well, but because there are certain very strict restrictions in terms of what we can and can't do. First of all, we have that hard barrier of about 1820. We can look at 1500, but we'd be looking at the mood of the elite, or the mood of the literate, whatever term you want to use, not the average. We can hope to look at other countries, but then we're going to have to digitize their books. And a normal grant is not big enough to digitize 8 million books or whatever we might need to do. So we're going to have to again think outside the box. What we wanted, and this time I was sort of thinking, what is it that we really want? We want a universal language that everybody speaks in the whole world, and we want that language to be a language of the emotions. So it's extremely good at picking up mood. It seemed like we were asking for a lot, but we weren't. Both of those terms have been used to describe music in the past. And so that's exactly what we did. But this time I teamed up with a bunch of computer scientists rather than psychologists, and you'll see why. So the method here is going to be vaguely similar, and so I'm going to rush through it a bit faster. But I'm going to point out where the similarities are. So we need that corpus of language, but now it's going to be a body of music rather than a body of language. So we just look at popular music. And in particular, I'm going to focus on the most popular chart hit in the UK. Right, so this seems like I've narrowed down from 8 million books to one corny song, but actually there is a logic behind that. We, of course, looked at sets of songs, the top 100, the top 10, but I'll tell you a bit more about that later. So we identify the most popular song each year using standard techniques, the charts, downloads, etc. And then we use a machine learning algorithm to try and extract mood from that music. We don't have psychological norms that can do that for us in general, although we have a few tricks that we can pull out from, once again, from psychology that are going to help. But we're going to have to create a machine learning algorithm that is effectively the equivalent of our norm, that can tell us what this bit of music means in terms of happiness, generating that number that we need, that we had before. The way we do this is a technique which some of you may have used before if you've used machine learning, but you effectively have to train a machine learning algorithm to see the relationship between data and the solution that you want. So the way that we normally do that, depending upon what sort of machine learning algorithm that you use, but the standard way is to take problems where you already know the answers, present to the machine the details of the problem and the answer, and then ask it to see the relationship between the details that you provide and the answer that you've provided. So it's essentially pattern recognition. It sees a bunch of stuff and it sees an answer and it tries to build a model that fits the data that you give it to the answer that you give it. The way that we did that was we had a set of 744 songs spanning a bunch of genres, which have already been analysed by psychologists, musicologists, to give us a clear valence score, much the same as with text. So we took 619 of those. We gave the machine learning algorithm 191 different variables to use. So that's 191 different variables about music. And then we asked it, and we showed it the answer to the question, how happy does this music make you feel? And then we let it build its own model. And where did we come up with 191 variables about music? So those of you who know something about music might be thinking, well, there's harmony, melody, there's key, and you might go through another and you're thinking, but 191. The reason we have so many is we think of music in this paper, at least, as a wave, as a physical wave. So if you think of music as just a physical wave, you can very quickly see how you can develop lots of different variables, slopes, widths, various differences, a variety of different things. So any conceivable thing that you can use to measure a wave, we converted it into a variable, we stuck it into the model, and we said to this machine learning algorithm, which of these various variables allow you to correctly identify the answer to the question, how happy does this music make you feel, given that we tell it the correct answer. We do that with 619 songs, and we save the 125 to test whether the model built by this machine works or not. And we use something as mundane as R² to tell us whether it's doing a good job or not. We do that in an iterative way. We constantly tell it, you're not quite good enough, try again, until we're happy. When we do that, when it can consistently hear 45 seconds of a song and tell us how happy that song makes us feel from this set of 125 where we have not told it the answer, if it can consistently get that right, we then allow it to do the same thing for the #1 hit in the UK between 1972 and 2009. That's essentially what we do. We do all the same validation exercises, so I'm not going to bore you going through all that again, but we're going to do exactly the same thing, correlating it, checking things, same routine again. We're going to call it the Music Valence Index this time, and then we're going to retrospectively change the name of the National Valence Index into the Text Valence Index, because we now have 2 valence indices, one based on text, one based on music. And we're going to see how they perform in a horse race. So this is a slightly dubious econometric technique where we're going to effectively have a regression where we put the music valence index, the text valence index, and why not GDP as well, and see which of these 3 performs best at predicting actual survey-based well-being from 1972 to 2009. And that's the reason why we chose that period of time, because we have Eurobarometer data, once again, reported actual happiness data from surveys. We have our national valence index. Of course, we have GDP, because we always have GDP. And we've got the music valence index. So we're going to pitch them against each other. And what we find is something truly remarkable, which is that the music valence index does really, really well. So just to remind you, this is one pop song versus 8 million books, several 100,000 newspapers, and it's predicting national mood better. That is astonishing. Maybe too astonishing now, probably you're thinking this guy's a fraud. But I can explain a little bit about why this is happening because of what we did next, which was this was supposed to just be a bit of fun, it's easy. Then we thought, right, now let's look at the top 100, top 10, top 1,000. Let's do it properly. It gets progressively worse every time you add a song to this list. The reason is obvious once you start thinking about it. Think of the 100th most popular song, the 1,000th most popular song in the UK at a given time. Is that going to reflect the average mood of the average person in the country? Obviously not. It's going to reflect the average mood of a small group of unusual individuals who like listening to very obscure music, quite possibly, but it's unlikely to pick up the average mood of the average person. However, the top song, the best-selling pop song, is going to pick up that by definition, because it has literally passed that test. It has been bought by most people. It reflects we can say the average. If you're unkind, you could say the lowest common denominator. But for whatever reason, the most popular song is doing the job of picking up the mood of the average person. And in many ways, music is more effective, perhaps even than publishing, in terms of bridging that gap between demand and supply. And as I said, music is a language of the emotions. It's all about emotion. Books suffer from a big downside when you're trying to detect mood, which is they also contain a lot of information. Now, I wouldn't normally call that a downside, but if you're trying to measure mood, it is. It means that text has a mixture of emotional content and informational content, which music does not have, or at least music is skewed heavily towards emotion. Okay, so I'm going to sum up. I think I've got time to do that now. I've still got 10 minutes? Yeah, fine. So I'll sum up, and then there should hopefully be time for questions. This summing up is going to include what I'm doing now and what I'm doing next, by the way, so there's still a bit to come. So to conclude what I've said so far, I'm arguing here that big data and behavioral data science allow us to do things which we could not do before. We couldn't travel back in time and measure happiness 200 years ago because we couldn't bring a survey with us and stick it and pop into a time machine. But we can sort of do that by looking at big data that already exists from that period of time, and we can infer from that data what we want to know. And that's not an alien concept to an economist. It's not that far removed from revealed preference, I guess, if you want to be generous. So there are some issues with that, though. One is we've got extreme computational I don't know what I'd say, onerosity, if that's a word, but something that's very nasty, that takes a long time, and that we can do right now, which we perhaps couldn't do even decades ago. It's very, very difficult to get some of these measures working using even clustered computing. Sometimes it can be quite easy, but then we have a second problem, which I haven't really mentioned yet, which is every time you use machine learning to try and understand a problem, sometimes you get really interesting results, as we did, but it doesn't help you understand as much as you might think. The reason is that machine learning is by its very nature a black box. So we give it 191 variables, we ask it to compute a model, it computes a model, the model does very well, and we see the results. But you ask me to give you an intuition. What makes a song a happy song? I have absolutely no idea. I can stare at a 191 variable equation, and I cannot tell you intuitively what really matters. It's far too complex. So the problem with machine learning in terms of using music is that we can see the result, and we can do things with the result, but it's difficult to get any sensible intuition out of that. So either we have computational difficulty, or we have a lack of transparency in the mechanisms behind what's going on. So it's not ideal. There's still a lot of work to be done. But I think the argument that because we didn't have people asking surveys in the past, we're never going to understand mood in the past, that argument has definitely gone away. Now, I want to stress a few things before I move on to what I'm doing right now. I said that the methods were general, and all I've done is talk about happiness. But clearly, there exist things like valence, but for other things. I've mentioned things like fear and anger, etc. There are then things that are one step removed. There are issues, things like the concreteness of words. One of my long-time co-authors, Thomas Hills, has worked on humour, developing a norm for humour, so you can see how funny people were at different times in the past using these sorts of measures. And that's just psychology stuff. If you want to move into the world of, say, political science or economics, you can do what's called topic analysis. So you can pick any group of words you like, or any phrases, and then see how important they are and look at the context. One of my students has worked on, for example, looking at words surrounding immigration and looking at how often they pop up, in what contexts, whether they come with positive or negative valence, and how this correlates to real-world events, say in the US, by looking at congressional speeches for the last 200 years. So you don't have to restrict yourself to psychological concepts, mood, etc. You can go beyond that, look at anything you like, by developing a set of words, creating your own norms, and then delving into the data and doing exactly what I've just described my student did. Right, to tell you about what I'm doing now and what I'm going to be working on in the future, there are a whole bunch of stuff. We looked at lyrics. That's something I didn't talk about because it's really not very interesting. Lyrics are somewhere in between music and things like books and newspapers, but they're really worse than both. Lyrics provide us very little compared to millions of books, millions of thousands of newspapers. The size of the corpus is tiny. And of course, lyrics are a little messier than music, so it's sort of worse than both. So lyrics, I don't think, is a very interesting thing to look at. Unfortunately, I say that having looked at it and wasted some time in it. But in any case, right now I'm doing some other, I think, interesting things. For example, looking at different genres of music and text and trying to look at the underlying mood of different subpopulations using those genres. So we know certain sorts of people listen to different sorts of music. In America, there are different sorts of people that listen to country and western or listen to R&B, for example. And if those types of music reflect subpopulations, then the mood embedded in different types of music should reflect the mood embedded in different subpopulations and will allow us to track these over time. We can do the same sort of thing with text, looking at what sort of newspapers and books different subpopulations read. Then we need to check whether things like music really can be used globally. It works well in the UK, but does it work well outside the UK? And I think the final thing that I've spent an enormous amount of time working on, I could spend literally hours talking about, are micro-level analyses of the extent to which language really does contain emotional information. So these are situations where we ask people in laboratory experiments to write things, and then we see if other people can detect the emotional content or the personalities, the mood, even predict how those individuals are going to behave based on the words that they use. So this is a snap back to micro-level stuff from macro-level stuff. But the aim is to understand what the limits are, what we can really do with language, and what we can really do with this sort of psychological data if we want to understand behavior and if we want to understand actions and decision-making. Okay, I think I'm literally about to hit 40, which is exactly what I wanted to do, and allow 5 minutes for questions if anyone has any questions. If you don't, that's absolutely fine. Oh, quick point. even for the stuff I've finished, the work is ongoing, it's never ending. So if you have any comments at all, please send me an email about any of the stuff I've talked about. All the papers are on my website. They're mainly science-style papers, so they're very short, which is a huge advantage. So take a look by all means, and hopefully there'll be something of interest. Thank you.